Hey, thanks, Luke. My name is Mihai. I'm the CTO for Cloud Native and Red Hat Solutions at the IBM Cloud Solutions Center. I also got a number of Red Hat certifications, working my way to RHCA, and I'm gonna share today some of the lessons learned in working with the container ecosystem from Red Hat, Podman, Docker, Quay, as well as some of the newer tools like buildah and skopeo, and how those tools can help to solve problems in the container ecosystem, and how migrating to tools like Podman and skopeo and buildah can help automate some of these workflows. So just to give you a brief overview of what we've done in the previous sessions, or what some of the scopes and goals are. On day one, so the previous session, we've installed the tools Podman, buildah, and skopeo. Today we're going to focus mostly on building and publishing images to a container registry. And we're going to use Quayio as our container registry. And in day three, we're going to deep dive onto a Kubernetes platform, install code-ready workspaces on a workstation or a laptop, create a new project, let's say WordPress, set up MariaDB, set up authentication, users, deploy various databases with secrets, create routes, and scale the application out. And I'm also going to introduce some new technologies like the operators, which make managing databases really, really easy. So you push a button and you get a cluster, and you have features like backup and restore. Basically, all of the operational aspects are automated as part of the operator framework, and we're going to see if we can migrate our application from a regular container to something more advanced like an operator. Just a couple of resources and links to get you started. Podman.io, buildah, and skopeo all have their own links. You can watch the previous session for a few more details. But given that I see quite a lot of new folks, today I'm going to give you, the 10,000-foot view, just to give you a quick 10-minute recap of what we've looked at in our previous session, but also to introduce a couple of new concepts and more advanced uses of the tools. So first, Podman. Podman, think of it as like Docker on steroids. It manages pods, containers, and OCI-compliant container images, with some interesting exceptions here. It can actually be run as a regular user without requiring root or a daemon. It can manage pods, so groups of one or more containers that operate together and share a network. And this is kind of like a way to do something that you might do with Docker Compose or even a Kubernetes slide. It lets you import Kubernetes definitions using Podman Play, so you can run a Kubernetes specification locally on your laptop without installing Minikube. And most important, the security is very tight. So if you actually run Podman, you'll see that all containers are using a fork exec model. So there's a parent Podman in your user, and then from there, it will fork various processes. You can also run containers as root if you want to bind to a privileged port, but in most cases, you'll find that not to be necessary. Buildah is a way to build container images without using a Docker or Docker engine. Why might you want to do that? Well, not only for security purposes. Let me give you a very specific example. Let's say that you're building a container registry and you want to have capabilities for building those container images without using a Docker engine, right? You want to integrate it as part of your CI/CD tooling. Well, buildah helps you build those images basically without having to rely on a container engine to make that happen. It can do so locally, can do so without root. So it's very, very handy, and it's integrated within the same ecosystem that you see here. Skopeo lets you move images around. So you can copy images between container registries, you can inspect them, you can get image layers. You can even use image signatures to verify images. So with that being said, I'm also going to explain some interesting sources for container images. So the Red Hat Software Collections library is for developers that need the latest tools, and they're available on every CentOS or RHEL system. It's basically a way to get around the fact that the life cycle of a more stable Linux distribution like RHEL or CentOS or tends to be slower than some of the development tool ecosystems, right? So these are containerized developer tools. And then you have the Red Hat Container Catalog. These are enterprise images that have gone through a QA process, and they're updated on a regular basis, and they're curated. To put it bluntly, it means that there's a team of folks behind it going through each and every container image to make sure there's no holes and no issues hiding behind it, and you have some kind of a vendor support. And then you have Quay.io, which is similar to Docker Hub. Anyone can use it, anyone can upload containers there. However, it has a couple of interesting features. It can also build containers from a Docker file. It can scan images with Claire for security vulnerabilities, and you can deploy Quay privately within your organization. Like I've mentioned before with Skopeo, you can move container images easily between any container library. All of these tools build OCI compliant images. That means that you can use them with JFrog Artifactory, you can use them with Quay, you can use them with Docker Hub, you can use them with any container registry. I've also introduced universal base images, and we're going to build an image based on a UBI today, and we're going to upload it to Quay. So what's a universal base image? Well, you'll often see that images in the container ecosystem tend to be built on Alpine Linux or Ubuntu or some other distributions. But they're not generally designed for enterprise software, or they're not designed with security in mind. They often don't support SE Linux, or they're missing a number of key features, or they're not updated for security vulnerabilities. So Red Hat has put out a free-to-use, freely distributable image based on RHEL, Red Hat Enterprise Linux. It comes with security updates, fixes, and a number of use cases as well. So it's not just a base image. You actually have a base image based on RHEL 7 and based on RHEL 8 with minimal and init images available as well. So an init image runs an init system, as the name suggests, like systemd. It's a bit closer to a VM, right? It can run multiple processes. You don't have to set up your supervisor D, and it simulates init a lot better. And for those of you asking, why the hell will I want to do that? I can give you a very concrete use case. So I'm running Ansible Molecule to test a lot of things like deployment of applications in my CI/CD system. So as I test my Ansible roles, I'm spinning up a UB init image, which is based on RHEL 8. So I know what it's based on. It has systemd. I can run systemd commands to start services. I can install a service like Apache, and I can use a systemctl start instead of hacking up a script to start my Apache, which means that I can test my Ansible molecule role without having to spin up a VM. I can do it in a container, and I have all the benefits of an init system. I can start and stop services, and I have a lot more features here. Obviously, it's not for every use case, but there are cases where that kind of flexibility really helps. You also get a set of language runtimes. So there's, UB8, Python 3.8, for example, as an image that's built upon the UBI. And all packages come from RHEL, so you can see the security updates and features there. And they're designed to work with SE Linux. They're designed to work with unprivileged containers. So you have a bunch of features in there. They're also designed to provide you a health index. So if you're trying to figure out, hey, is my image secure, or what the hell is going on with this image? Well, you'll be happy to know that somebody's looking at the images. If somebody hasn't looked at this image in a couple of weeks, the health index will start turning bad, right? Even if the image is technically secure, is being scanned with Claire, is being scanned with static analysis tools. It has the security updates from the RHEL repository. If it hasn't been updated in a while, you'll also see the health index change. Just a caution there. Look, if you can put some of the folks on mute there. I'm getting a bit of feedback. Somebody's Darth Vadering in there, so
yeah,
look if you can. Yeah.
All on mute.
All right, thank you. Now, for those of you who've used Compose, you'll find that Podman Compose is also available. You can use Podman as a backend. You can run unmodified Docker Compose files, even rootless, with no daemon required, with the only dependencies being Podman and Python 3 and PyYAML. But my advice is you don't really need that, right? So you can actually generate a Podman play to import a Kubernetes definition, or you can use a Podman pod. A Podman pod basically links two containers together, and it lets them communicate even over an overlay network in user space if that's the desire. All right. So just to get started, so if you're following through in this tutorial, and I'm going to publish everything here in a bit along with some exercises that will help you out, it's fairly straightforward. Doesn't matter the distribution, you'll find there's a Podman version. The only caveat is that Podman, like just all of the container tools, does require a Linux system to work. With Docker and the Docker tools ecosystem, if you're using Docker Desktop, you'll find that there's actually a lightweight Linux VM in the backend if you're using it on the Mac and the Windows. With the Podman ecosystem and tools, there's no such thing as a Podman desktop version, right? So you'll have to get a real Linux system, or you can use Podman remotely against a real Linux system to get these features and capabilities to work. One of the interesting changes in Podman is the ability to or the support for cgroups version 2, so additional security capabilities here, as well as running rootless containers. Now, there's a bit of magic happening behind the scenes. So, let's say that I have a user. This is my UID. It's UID 1000. Uh, you might not be aware of this, but if you're running a container and you have root inside the container, that root maps to the root on your machine, right? So there's some interesting things happening there with the UID and permissions and C groups and isolation and namespaces. And it's really not a good idea to run containers as root on root with root inside the container with privileged ports. You can get in a lot of trouble, especially if you're not using something like SE Linux or um, to secure the host. And escaping from a container tends to be commonplace, especially if you have privileged containers where you're giving them a lot more capabilities than they should have and they can access your host system. SE Linux can block most of those things. But then again, for anyone who's used SE Linux, I'm willing to bet, I'm going to use the poll feature in here. Raise your hand if you keep SE Linux turned on your system. And I see no hands, right? So folks tend to turn SE Linux off quite fast, and I don't know why, right? Well, I do know why. The user interface and the user experience isn't the nicest, but it genuinely prevents, like 80% of container escape vulnerabilities. A lot of the recent issues that, were seen in the Kubernetes ecosystem were prevented by SE Linux and so on. So here's the idea that let's say that you have a container and inside your container you have MySQL. MySQL inside the container runs as the MySQL user. It does not run as the root user. And the UID of the MySQL user inside most containers happens to be 27, right? So that 27 is going to map to UID 100,026 because the UIDs, if I use this command, podman share, and I look at my UID mapping, is going to start mapping all of my container UIDs to 100,000 plus, right? So it's from 0, so you need to remove 1. So if you have 27 inside your container, you have 100,000, or is this a million? Anyway, numbers are hard, right? And you're going to map it to this. Now, nobody wants to remember this and give privileges by hand. So Podman introduced a very, very simple command. If you want to share a volume on your host to a volume inside your container, you say podman share chown 2727 test, and now you see the mapping has been done automatically for you on the host, and now you can share this volume with your guest. So that's basically some of the caveats and interesting facts about running rootless containers with Podman. Let me just open it up for some Q&A first on the why and what exactly does Podman help with, and then I'm going to deep dive into building some container images and looking at Quay. Questions?
Why would
And now, yeah, go ahead.
Oh, this is Mark White. I just wanted to know, why would I use Podman over anything else?
Well, a number of reasons. So one of them would be security, right? So Podman has been designed with security in mind. It builds the same OCI compliant images that you typically get with Rocket or Docker or any of the other container tools. You can run them rootless. And it also has a number of capabilities like playing back Kubernetes specifications. And it's available out of the box on CentOS or RHEL type distributions without having to install and start and manage a full-blown Docker engine. At the end of the day, it doesn't matter what you're using to build your containers, as long as you're following the best practices when it comes to building unprivileged containers. So not running everything as root, building containers with the right UIDs, and ensuring that the container images that you build come from a trusted source and that the images that you have are updated. You're free to manage all that ecosystem yourself. There's nothing wrong per se with using Ubuntu or using Alpine or using any other image as your source. However, do keep in mind that if you're grabbing a container image that's been built in some strange way, typically from the public, chances are the upstream images aren't updated. Chances are they might be running with more privileges than they should be. Chances are nobody's looking at the security vulnerabilities and inspecting that image in the long term.
And
So it's more of a best practice for enterprise. Yeah.
I guess that's part of what what I'm asking on what you just said is that shouldn't I want to have it run from a program that I know that you have to sudo, so you just can't do something? You understand what I'm asking?
So the question would be, would you want to ensure that users can't run a container and only root? Yeah,
Cancel it. Correct. Yeah.
yeah. So let me answer that one as well. Actually, by default, you can't run a rootless container unless you set up Podman to run rootless containers. So basically, your users can be blocked from running Podman, right? It's a privilege that you assign to users as part of user permissions. So that's part of it, right? You don't necessarily give every user root permission. Second, when you're building a container, let's say that you're building a container image. You're building that container as root. Don't be fooled. If you're using Docker and you're using Docker as a regular user, there is a Docker engine in the back that's running as root, right? So every single step that you take while building that container happens to run on your system with root privileges. And if something goes wrong, that process, if it escalates outside of your container, will have full root privileges on your machine and can do a lot of stupid things. The same thing when you're running your containers in production. If you're trying to achieve isolation, right? If an unprivileged container happens to escape its container boundaries, that has root on your container host. Now, if you're building and you're running containers designed to run as a regular user, if that container happens to escape, it's now a regular user. It's not root. So you're limiting the damage and the stupidity that can happen from situations like that. It doesn't have to be a security vulnerability. Sometimes it can just be improper use, right? You've given access to the wrong directory, or it does something stupid in proc, or it eats up all of your resources. So generally speaking, you want to follow the privilege of list privilege and give your containers the minimum required permissions to do whatever they need to do. So in the case of building a container image, you really don't want to build your container images as root. It's just as bad as not creating a regular user on your Linux workstation and logging in as root and doing everything as root, browsing the web as root, using Firefox as root, if that makes any sense.
It does completely, and I thank you for answering me. That you answered me completely. I appreciate it.
Grand. So thanks for the question. It's a good question. Any other questions here? Just on the why and what's going on and what's happening. All right. So just a quick recap from what we've been doing in the previous session. Podman is fairly straightforward. You can use any container registry, so Docker.io, registry access.com, Fedora, CentOS. Same kind of syntax as Docker, so there is a one-to-one mapping between commands in Docker and commands in Podman. There is even a Docker Podman command that makes Docker run Podman, right? It's just an alias. You can pretty much expect all of the commands to work as expected. You configure your registries, and then you can use various commands, including inspect and history and pull images and run. So fairly straightforward. Podman run, name Ubuntu, hostname Ubuntu, interactive, bin bash, and you have your session. So just to recap some of the things that we've done in the previous session, we've created a sample container image to serve a web page. So here you see, for example, I'm using an HTTPD daemon. And the interesting bit here is that this HTTP image was configured with port 8080. So does anyone on the call know why, when running Podman as rootless, I'm running it and I'm binding services on port 8080 instead of 80 inside the container image? And you can type it in the chat as well if you think you know exactly the reason. So would it work if I was going to do a Podman run and use port 80?
It should, because port 80 is web traffic.
Well, it would work if I were root. So I think Juan Carlos has the answer. The root permissions over ports less than 1023. So the first 1024 ports are called Diana privileged ports, and they require administrator on Windows and root on Linux and Unix to be able to bind the service to the port. So a regular user cannot use a port less than 1024. For good reason, for security. Let's say you're running a server and you have a bunch of users and you run your main web page, and then random Joe gets in and binds a service to port 80. It's really insecure, right? Somebody can hack your machine. They don't need to do privilege escalation. They can just start an HTTP server on 80 and take over your website. So if they manage to crash it, right? So the idea here is, when you're running a service inside Podman, pay attention. Is the image being built with a port less than 1023? That means that the image was not designed to run unprivileged. Now, just because you're running things in the namespace of a container doesn't mean you need to run stuff as root. It's still a very bad practice. So, okay, but if you're running, would it still work? Well, yes. So I can actually bind port 8080 inside the container to port 80 on the host by running Podman with a root privilege, but inside the container is running as a regular user. A better pattern would be to run a redirector or a proxy or a pod. So in Podman, you can actually create a pod as root. The pod just redirects port 80 to 8080 inside the container, right? While your service runs unprivileged. So it's the same pattern that you have with a router in OpenShift or a load balancer in other scenarios. And when you create a pod, you can actually redirect that port to multiple containers as well. So instead of somebody typing, HTTP port 8080 every time, they would type 80, and then there's a redirect happening. The redirect will not run any service, and it will take you to an unprivileged port inside the container. So it's like having your own DMZ. Okay, so moving forward, same commands as you would with Docker. You have podman ps, inspect and logs, stop and start to start the container. You have various run commands as well as environment variables. So if you want to pass something to a container, here's a good example. If I'm deploying a MySQL image, right, that requires things like users. -e is an environment variable. It gets passed inside my container, and then my container is using that to create a database called MyDB and set up a password. And -detach means it's running this image in the background. You'll notice I didn't attach a port to MySQL. Does anyone know why I did not attach a port to the MySQL image? Why I'm not exposing any port?
Because it already has its own part.
Well, it has 3306, right? But the idea is that when you run the expose command or the publish command, it will map a port on your host to a port on the guest. But if I'm building a WordPress website, right, um, do I want every random Joe on the internet to access MySQL, or do I want them to access Apache? There we go. I don't know who you are, Juan Carlos, but check out the IBM website. If they're hiring, you should apply. So very good answer. Right, keep the isolation on the container network. So your user will come in, they will hit your WordPress or your Apache website. Apache that you see in the previous image, like you've seen that I'm exposing a port on 8080. So I have the pod that redirects port 80 from where your user comes into http example.com. From there, it goes to port 8080 inside to hit your Apache. And your Apache is going over the container network, private network, to talk to your MySQL container. So you're not putting your MySQL container on the internet, which is very, very useful. So that's another good example there. Again, same kind of situation. If you need to look inside your container, you can use exec command. So I can use podman exec the name MySQL and then bash, and then I can log in. I can log in as a regular user as well. So as you can see here, I can execute a container login image. I can monitor what's going on inside the container. So, check processes or check statistics and usage or check the ports. So as you can see here, I only have 8080, right, from the host to the guest. I can even be more specific. For example, I can bind 127001 on 8080. So I'm not binding on all interfaces on my host. And then I have another process like HA proxy or a proxy, which only talks on local hosts. So that way people can't hit my web server directly. They always hit my load balancer. And I have free container images, just as an example. I can also build and commit images. So we're going to do this exercise hands-on in just a bit, right? I can run an image. I can give it a name, a host name. I can start an interactive session with TTY. So there's a -IT flag. And I can run bin bash. I can run a bunch of things. And then I can use the diff command to see what files have been added and changed to my image. And then I can commit my image. And when you commit your image, you can even change the entry point. So for example, if I'm installing Apache, I would actually change the entry point of the image, not to bin sh, but to usr bin httpd minus big D, right? So that will start Apache when I start my container. I can set if my image is a tarball. I can load the image back into a container registry, and I can also push it in various other places. Now, one thing you might need to do if you're using somebody else's image, right, is to change the ports. So I told you, security is important. So if your container is listening on image port 80, hey, let's take the container, let's change the port from 80 to 8080, and let's build a new image based on it. Let's tag the image, and let's push it to our container registry as our new image, which now listens on port 8080. Let's create a local volume. So here's the data volume that I'm using and I'm sharing. and then let's see how it runs. So I'm running through this a little bit fast, but I'm going to go in hands-on in just a minute and show you exactly. I'm just giving you an overview of taste of what's to come, right? So here, for example, I also have SE Linux permissions where I can define what my container can access. So why the hell would I do this? Well, SE Linux is really cool. It's also designed by folks who don't like people, right? So the commands are not designed for humans. But I'll help you understand them. So I have SE manage F context. So I can manage the file context of this directory on my host called MySQL data and every file inside it to set this as a container file T. This means that the container can access this directory. If my MySQL container tries to escape from that directory or to access any other file on my host, it will be blocked by SE Linux, not just by the container. So they can help prevent a lot of escape situations when your container has access to files on your host. So end to end, the command to run something like MySQL will be Podman run. I'm giving it a name, a volume, MySQL data on my host, a user, a password detach, and then as you can see here, I have container T files and permissions, and I'm able to use my container properly. I can also start my containers at system start. So let's say I want to have a Redis container that starts with my system. I can create a systemd specification here, a unit, a service, and an install. As you can see, it will start and stop my container. And I'm also using SC Linux booleans to let systemd start Podman. So this is one of the exercises we will do in our next session as we deploy it to OpenShift, creating a WordPress and MariaDB pod. But now, for the main event and the main course, we're going to go to a Quay.io tutorial. So let me spin up a console here, and let's take a look at how we can build containers using Quay.io. So with Quay.io, you have again Podman commands, right? So let me go into this directory, show you that I have a Docker file. My Docker file is building an image based on UBI 8 minimal, and I'm using microdnf, which is kind of like YAM, right? To install Apache and create a sample test page and export the port. I'll show you how to change it to 8080 as well. And I'm gonna go Podman, login, Quay.io. I'm gonna log in with my credentials, and once I'm logged in, let's say that I want to run a container. So Podman run. I'm gonna say name UBI 8 HTTPD. I'm going to start a minimal image and I'm going to run bin bash. Obviously, I already have this running. And let's try that again. And as you can see, I'm in a minimal container, right? So I'm going to do a micro DNF update -y to update to the latest rel. As you can see, very few packages were updated. And then I'm going to go install HTTPD, and I have a web server installed. And then I'm going to do something here like clean my system so I don't have any remnants. So for everyone who's been using images like Alpine Linux, this is a great alternative. It's really fast, it's really useful. And now I have a container image. Now, I could do the trick that I've showed you, right? So I can do a commit and I can give it an entry point. Or I can build the same image with the same commands that you've seen from a Docker file. So I can do podman build -t, and I'm going to build it. And as you can see, I'm tagging it with this tag. The image is now built. And now I'm tagging it with Quay.io. So once I have it tagged with Quay.io, I can actually test it. And I have an image that's tested and working. And I'm going to say, okay, the logs look fine for my image. As you can see, the text that I put here, Apache and index works. The image works. Localhost works. The only thing left to do is Podman push. And now the image is being brought up onto Quay.io. So let me show you what's going on here. As you can see, I now have a UBI image. You can pull it and play with it. So Podman pull Quayio Mihai UB8 HTTPD. And I can also do this. So if I'm going to go to the builds, let's say I want to build a new image from this one. I'm going to create start new build. And you've seen how I've built that image manually, right, on my laptop. Well, thanks to buildah, you can just upload your Docker file here and click start build. And Quay.io will do all of that for you. So if you don't have a Linux machine, there you go. You can generate a build directly on Quay.io. And as you can see, the build happens here, and you can see a lot of the metadata. So it's very, very useful to see everything that's happening in your VM in a very nice, in your container in a very nice interface. So you can also go here and you can take a look at the tags and give more information and description to your image. Apache HTTPD minimal image on latest route 8 UBI. And you can save the changes. Now, with that being said, I'm going to have one more teaser for you. So as I take questions, please ask me any question at this point. I'm going to give you a teaser of what's going to happen in our next session. So in our next session, we're going to move from Docker and Podman and local builds and containers and Quay to take some of these images that we've built and start to deploy them on an OpenShift cluster. So we're going to install a OpenShift cluster on a laptop. You'll get the tools and you get the information on how you can install it yourself. We're going to play with operators, which let you install, for example, TIDB, for example, is a MySQL operator. So it will create clusters for MySQL that have seamless upgrades, lifecycle, deep insights, and all these extra capabilities. And we're going to install WordPress and scale it up, create a couple of things, and play around with the operator framework. I'm also going to give you a taste on one of the newest features that launched with OpenShift 4.5, which is the ability to run virtual machines inside containers. So you can actually run a full-blown VM, right, using KVM inside a container. So if you need more than an init image, if you need to run a virtual machine like RHEL 8, Fedora, Windows, you can actually do so straight inside your container. So you can pretty much access it, SSH into it, and play around with the system on top of OpenShift and integrate containers and VMs running in the same space. So let me stop it here and take a couple of questions before we part. The sandwich stack, yeah. So Juan, just to give you some insights, um, we can put Kubernetes in Kubernetes so you can Kubernetes while you Kubernetes. We can use OpenShift to install OpenShift on bare metal. So actually, if you see the cluster that I have here running on IBM Cloud, I have a bare metal worker node. So I can spin up as many bare metal worker nodes that I want. So I can say bare metal, right? So I can spin up, a big machine. And then on this bare metal cluster of OpenShift, I can spin up an OpenShift cluster or 100 OpenShift clusters, or I can spin up OpenStack and install it. I can install, so I can install OpenShift in OpenShift. And you'd be surprised, there is a use case for that, which is developers, right? If I'm a developer and I want my own OpenShift cluster or my own Kubernetes cluster, well, there you go. Here's a cluster. And I'm going to do it cheaper than deploying and managing individual clusters. A cluster of clusters, yeah. Exactly. So Juan makes some good points. If you have teams and you want to give them auto provisioning capabilities, I'm not going to give them access to my IBM Cloud account because the billing is going to get very high very fast. I'm going to give them this cluster that I've created for them, right? And I know the resources, I know the footprint. And I go, guys, you have access to this cluster. Deploy as many clusters on top as you would like. And OpenShift has a tool called API Installer, which is Terraform to bootstrap itself across clusters of bare metal servers. So it's very fast to deploy a cluster in half an hour. Yeah. So any questions on the overall scenario, Podman, OpenShift, containers, or anything you'd like to see in future sessions? And by the way, you can even say, just import the images that I have in VMware, and it will convert them to KVM and run alongside your containers in your containerized platform. All right. So I don't see anything else in the chat. Anyone else want to go off mute and ask a final question? All right, Luke, on to you to close the session and announce the next meetup.
Yeah, brilliant. Thanks, Mihai. Appreciate that. And yeah, guys, thanks for all the Q&A and the message in the chat. It definitely makes the sessions a bit more interactive. So that's great. Yeah, so as Mihai was alluding to there, next Friday will be the third and final part of the series. But if there are any additional sessions you like, any topics you want us to cover, go into a bit more detail with, I'm probably putting Mihai on the line here, but I'm sure he would be happy to deliver those sessions as well. So yeah, I'll get the recording up a bit quicker than last time, and yeah, we'll officially announce on the meetup.com momentarily the session for next Friday, and I hope you all can make it. Thanks very much.
All right, and talk to you. Bye-bye.
Cheers.